Section 8.4 has to do with rectangles, which is one type of parallelogram. So far, we've talked about quadrilaterals, which are just four-sided figures. One particular quadrilateral is a parallelogram. Now, parallelograms, we know that opposite sides are both congruent and parallel. We know that opposite angles are congruent. We know that consecutive angles are supplementary, and we know that diagonals bisect each other. Those are the characteristics that we've learned about a parallelogram. Well, today we're going to go on and talk about a rectangle. A rectangle has many of the characteristics of a parallelogram, but it has a few things that are more specific. So, a rectangle, opposite sides are both congruent and parallel. So if I draw a rectangle, okay, opposite sides are congruent, opposite sides are parallel. So this is congruent to this is parallel to this. This is congruent to this is parallel to this, okay? So on a rectangle, it's just like a parallelogram. Opposite sides are congruent and parallel. Opposite angles are congruent. So this is congruent to this is congruent to this is congruent to this, and this is congruent to that. So that's also a characteristic of a parallelogram. See, the thing is all rectangles are parallelograms, but not all parallelograms are rectangles. I also know that consecutive angles are supplementary. So this plus this is going to equal 180 degrees. This plus this is equal to 180 degrees. This plus this is equal to 180 degrees. And this plus this is equal to 180 degrees. Okay? So those are the same characteristics for both of those. Now this one is where it wavers a little bit. Diagonals are they bisect each other and they are congruent. So the part that we have added, they bisect, so I know that that is equal to that and this is equal to this. It says they're congruent, so that is congruent to that, which means all four of these little sections would be the same. That is what makes it a rectangle and not just a parallelogram. The other thing that makes it a rectangle is that all four angles are right angles. So a rectangle has four right angles to it versus just a parallelogram does not have to have four right angles. So that's how a rectangle is more specific. All rectangles have the characteristics of a parallelogram plus two more. So here's some examples. I have quadrilateral. It tells me that this is a rectangle. So therefore it has all those characteristics. So MO is a diagonal and PN is a diagonal. And remember, if it's a rectangle, diagonals have to be equal to each other. It tells me that MO is equal to 6x plus 14. PN is equal to 9x plus 5. So let's find x. Well, in a rectangle, diagonals are equal. So 6x plus 14 is equal to 9x plus 5. I need to solve for x. If I subtract the 6x, I get a 3x. If I subtract the 5, I get a 9. So x is equal to 3. Same concept down here. It says that this is a rectangle, so I know diagonals have to be equal. It gives me the measurement of the two diagonals. So I want to set it equal to each other. So I have 6x plus 4 is equal to 7x minus 4. So I'm going to subtract the 6x and get an x. I'm going to add the 4 and get an 8. So I find out that x is equal to 8. Sometimes they do ask you for the actual measure of the diagonal, so make sure you read the instructions. All right, here's another one. Quadrilateral LMNP is a rectangle. says find x and y. Well, you know that means that these angles are 45 or 90 degrees because it has 4 90-degree angles. So I'm going to take these two first. This plus this is going to have to equal 90. So I have 5x plus 8 plus 3x plus 2, and it's equal to 90 degrees. So that's an 8x plus a 10 is equal to 90. I'm going to solve by subtracting the 10. So I have an 80, and then when I divide by the 8, I find out that x is equal to 10. Okay? Now, in order to get this one, I would have to remember, if it's a rectangle, these two sides are parallel, which makes this and this alternate interior angles. That thing still keeps creeping up. So what I'm going to need to do is plug in here to find out the measurement of this angle. So 3 times 10 is 30, plus 2 is 32. Okay, so this is a 32-degree angle, which means that has to be a 32-degree angle. So I can say 6y plus 2 equals 32, and I'm going to solve for it. I'm going to subtract the 2. So I have a 30 here. When I divide by the 6, I find out that y is equal to 5. So I've solved for both the x and the y based on the fact that this is a rectangle. All right, then we have another theorem that has to do with these rectangles. It says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. And here's an example problem of that. It says you have a quadrilateral ABCD that has these vertices. Determine whether the quadrilateral is a rectangle using the slope and the distance formula. Now, they tell me that it's a parallelogram. If they had told me it was, if they told me it was a quadrilateral. If they had told me it was a parallelogram, I would only need to use the distance formula, because if I can prove that their diagonals are congruent, knowing that it's a parallelogram, I can conclude that it's a rectangle. But on this one, all I know is it's a quadrilateral. So first, I have to prove that it's a parallelogram. So -2, 1 is your A. Your B is 4, 3. Your C is 5, 0. And your D is -1, -2. Okay, so it says to use both the slope and the distance. Now, what I would use the slope formula for is to make sure that I have 4 right angles, or I could prove that it's a parallelogram. Let's do that. Let's prove it's a parallelogram. And opposite sides must be parallel. So I want the slope. This is using the slope. I want AB, and I want DC, and I want AD, and I want BC. So I'm going to use my slope formula to find each one of those. So I pick up my calculator. The slope of AB, I have -2, 1, and I have 4, 3, and it has a slope of 1/3. And then DC would be -1, -2, and 5, 0. And it also has a slope of 1/3. So I can conclude that this is parallel to this. Now I need to do the other sides. So I have AD, which is -2, 1. And I have -1, -2. Which is going to be a -3 right there. And then I'm going to do BC, which is going to be 4, 3, and 5, 0, which is also -3. So I know that this is parallel to this. Now, it says use the slope and the distance. So to prove that this is a rectangle, I would just have to use the distance formula to prove that AC would equal DB. Because remember, if it's a rectangle, their diagonals are congruent. So now I'm going to use my calculator and use the distance formula. And I'm going to find the distance from A to C. So -2, 1, and 5, 0 has a distance of approximately 7.07. And now let me try to find DB. So that's -1, -2, and 4, 3. And that has the exact same distance. So therefore, this is a rectangle, okay? So determine whether it is a rectangle. The answer is yes, because I know it's a parallelogram, and I know it's a rectangle because the diagonals are congruent. All right, your homework on this is page 228 through 229, 10 through 24 all, and 27 through 29 all.